find the LCD, that is the least common denominator, of the pair of rational expressions. So here we have two rational expressions. We'd like to find the least common denominator. So I'm going to look at my denominators, 2x cubed and 8x, and try and find the least common denominator. You'll recall that just with numbers for a minute, if we have two fractions, say 1/3 and 1/4, and I want to find the least common denominator of these two, what I want to do is I want to multiply each of these denominators by something, and I'd like to end up with those products to give me the same denominator, right? So here, if I multiplied, say, my 3 by a 4 and my 4 by a 3, I'd get a 12 in both cases. So that would be my least common denominator. In order to multiply by a 4 down here, though, right, I'm going to have to also multiply by a 4 in the numerator. In order to multiply by a 3 down here, I'm going to also have to multiply by a 3 in the numerator. Because what's that do for us? That goes ahead, and this 4 over 4, that's just a fancy way to write 1. This 3 over 3, that's just a fancy way to write the number 1. So all we've done by multiplying by 4 over 4 is we multiply by 1. Multiplying by 1 doesn't change anything. 3 over 3, multiplying by 1, not changing anything. So I still have a third, I still have a fourth, I just write them in a different way. Right? This way I'll have 4/12, and this way I'll have 3/12. So I'll have a common denominator. Of course, there's other ways besides using a 3 and a 4 that we could get a common denominator, right? Instead of using multiplying this by 4 and this by 3, I could say multiply this by 8. Of course, I'd have to multiply the numerator by 8 as well. And instead of multiplying this one by 3, I could go ahead and multiply this by 6. Of course, I'm going to have to multiply the numerator by 6 as well. This gives me a 3 times 8, 24. 4 times 6, 24. All right, so there's many ways to get a common denominator, and we'd like the least common denominator. So really, we try and multiply by the smallest things where we can get their two denominators equal. So it helps to look at the prime factorization of these two things, and whatever is in the prime factorization of this one, but not in the prime factorization of this, that's what I'm going to multiply by over here. And whatever is in the prime factorization of this one, but is not in the prime factorization of that one, that's what I'm going to multiply by over there. All right, so let's go ahead and look at those prime factorizations real quick. 2x cubed, of course I can write as 2 times x times x times x. 8x, I can write as 8 is 2 cubed, so 2 times 2, 2 times 2 times 2 times x. And we can look at these prime factorizations, and we say, okay, in this first one, in this 2x cubed, I have 1, 2, and 3 x's. All right, so what's missing in the second one that the first one has? Well, 2 of these x's are missing, right? This second expression only has 1 x. This first one has 2 x's, so I'd like to put 2 more x's down here. So let's multiply by an x squared, my 8x squared, or my 8x by an x squared, and that'll give me 2 more x's to work with in the denominator here, right? X times x. And if I multiply by an x squared, I'll have an x cubed. Okay, well, what's in my, let's just look at the original factorization here. What's in this factorization? 3 2's and 1 x. What's up here? There was only 1 2. And there was 1 x, there was more than 1 x, but there was the 1 x that was there. So what's missing from this one are 2 of these x's. So let's go ahead and put in 2 more x's, okay? So put in an 8x cubed. So if I want to put 2 more x's here, I'll have to multiply by a 4, okay? So multiply by a 4 in the denominator, I'm going to have to multiply by a 4 in the numerator. To multiply by the x squared in the denominator, I'd have to multiply by an x squared in the numerator. But that's neither here nor there. They're just asking us here, what's the least common denominator? Well, it's this thing, the 8x cubed. So 8x cubed is our least common denominator. If we wanted to go ahead and rewrite these two expressions so they have that least common denominator, I take this first one, multiply by 4 over 4, gives me a 4 over 8x cubed. This second one, this 5 over 8x, I multiply by an x squared over x squared, I'd get a 5x squared over 8x cubed. So here are, they didn't ask for this in the question, but the two fractions that are equivalent to these two that have that least common denominator.